Hey guys, today we're going to be talking about proportions. So let's start with the definition of a proportion. A proportion is two ratios or fractions set equal to each other. So here we have an example of two ratios, two fractions set equal to each other. You see here that 1/2 is equal to 5/10. We are going to be solving equations where, let's say, this 5 wasn't there. And we need to figure out what number went in that blank. And we're going to be using algebra to do that. So let's talk about that technique. If a proportion is a part of an equation, you want to cross multiply, and that's along the diagonals to get rid of the fractions. Then you solve it like a regular equation. So now we're going to start with our first example here. So we are given an equation that is two ratios or fractions that are set equal to each other. So since it's an equation, we need to cross multiply. So what does that look like? I need to multiply the 3 and the 9 and the 6 and the W. You don't necessarily have to draw these circles there, but I know for some people that is helpful. So I'm going to do 3 times 9, 3 times 9, and we are using the dots for multiplication now instead of the X. And then we're also going to do 6 times W. And then we go about solving it regularly. So we need to do 3 times 9, which is 27, is equal to 6 times W, or just 6W. From there, we do need to simplify, or we need to divide both sides by 6 because the operation here is multiplication. So we're going to use the inverse operation, and that's going to let us get rid of these 6's here because they reduce to 1. And we're left with 27 over 6 is equal to W. So a lot of people may stop here, but we also need to be careful because we can simplify. We can simplify this fraction because both the numerator and the denominator are divisible by 3. By dividing both by 3, we can simplify our answer. 27 divided by 3 is 9. 6 divided by 3 is going to give us 2. So that means W is 9 halves. You can also rewrite it as W equals 9 halves. Let's take a look at another example. So here we are going to cross multiply again. So I'm going to have 2x times 20 is equal to 5.5 times 3. And again, it's just the diagonals. If you wanted to do the 5.5 times 3 and put it on this side of the equation and the 2x times the 20 on the other side of the equation, that is okay. So let's just keep going with what we have. 2x times 20, we can combine these together because it's through multiplication. So 2x times 20 is 40x, and 5.5 times 3, for now, you are allowed to use a calculator for that, and that is going to be 16.5. From there, we solve it normally. So I need to get the x by itself. So the operation here is multiplication. So I use the inverse, which is division on both sides. That reduces to 1 and goes away. So I'm just left with the x. And then here you can type this into your calculator and you get 0.4125. So I want to leave it like this, rounded to the nearest hundredth. So I need to take my equal sign. Since I am rounding, it's now an approximation. So I have to use the squiggly line to tell me that is approximately. Because it's not exact since we rounded to the nearest hundredth. Let's see another example together. So here, this one's a little bit different because you can see we have two variables and we also have a lot of stuff in the numerator here. So when we have two terms in the numerator, these are all connected. So we should put parentheses around them to help us keep them together. So when we do the multiplication and we go across here, it's going to be 21 times the quantity x plus 2. And that is equal to negative x times 14. And from there, we can simplify. So here, since we have this multiplication with the parentheses, we distribute. 21 times x is 21x. 21 times 2 is going to give us 42, and it's positive. From here, again, these are not like terms. However, since it's multiplication, we can combine them. So it's going to be minus 14x there. And then we continue to solve it like a regular equation. So I need to get the x's together on one side. To do that, I'm going to bring this 21x over here because I already have the x almost by itself on that side. So I'm going to use the inverse operation. There's an imaginary plus sign there because it's a positive number. So I'm going to subtract 21x on both sides. This goes away because it reduces to 0, and I'm left with 42 is equal to minus 14 minus 21, negative 14x minus 21x, which is going to give us a minus 35x. And from there, we do need to get the x by itself by dividing both sides by negative 35, using the inverse operation because multiplication was there. And we're left with x is equal to something we need to simplify. I'll leave it like this for right now. That negative can go out front, it can go up into the numerator, or it can stay where it is. But we do need to simplify this right here because both the numerator and the denominator are divisible by 7. So we can simplify it. 42 divided by 7 is 6. 35 divided by 7 is 5. We have to make sure we don't forget that negative, and that is equal to x, and there is our final answer for that example. Okay, I would like you guys to try this last one on your own. So pause the video here and give it a try. Okay, so here's the solution for this last one that you tried. So you have cross multiplying 5 times 6 and 15 times the quantity x minus 1, because this whole thing goes together, so you need parentheses there. And from that, you get 30 on the left-hand side, and you have to distribute this 15 to get 15x minus 15. And then you solve it like normal using inverse operations. So I add 15 on both sides to get this to go away. And then I get 45 is equal to 15x. From there, I can divide both sides by 15 to get the x by itself. And I get 45 divided by 15 is 3. Or you can rewrite it as x equals 3. Either of those are the same. So that does it for today's lesson on proportions. Make sure you ask your teacher if you have questions or you need some explanation. Otherwise, have a good day, guys.